Working? Oh yeah, that's working. So let me share the screen.
Oh yes.
So I hope you're doing well. But because typhoon, so our class now is ahead of the other class. So I figured out how to make up the other class because the other section have a lot of class have to make up because of the holidays and things. So if you are jumping around over the sections, you be careful the announcement where the class is going, right? If you people jumping around, but I mean, although you shouldn't be jumping around, but I can't really check whether you jump around though. But I hope you attend your own section. That is the easiest thing. But even though I take attendance, I can't really make sure that you are on your own, right? But anyway, so what to go today? Today we will finish the first set of slides on descriptive statistics by going through the Excels. And as I said, I'm not assuming any knowledge on Excel, so I start from scratch to do Excel. Then probably we'll do it first half of this class will be done with the Excels. If lucky or not, then we will have a little bit more. But then we will start with probability today a little bit. Hopefully everything goes smoothly. Without further ado, let me quickly start. So don't worry, the homework will not be released until we finish the second set of slides. So, but now we are going to begin. So just a quick recap on what we've done. So in topic 1, we cover descriptive statistics. Particularly, we focus on basically 4 types of summary, right? We have central tendency, we have mean, median, mode, and dispersion is about range, interquartile range, variance, standard deviation, coefficient of variation, right? 5 of them. And shape, we have skewness and kurtosis, right? And you pretty much agree that probably except mean and median or mode, the dispersion and shape can be complicated calculation, especially the variance and all kind of stuff, right? And the second set is we talk about the covariance and correlation, right? Which measure how variables are related, right? So this is the formula, right? The covariance and also correlation coefficient. And probably you agree if you try the assignment, which we release soon after we finish the topic 2. You agree that the calculation by hand will be very complicated. Okay, probably the only time you do it for assignment part of it. And part of the other assignment is ask you to write down Excel code, which we will do it today, because in reality or in practice you would be using a software, right? But you need to know what you're doing, right? Because that is always the case. Is now people are increasingly rely on AI, right? Probably you might want to rely on the statistic analysis by AI, but I have to warn you that the usual ChatGPT now is not doing very well on calculation. They're doing many of the time they're doing wrong stuff. Okay, so that's why you need to know what's going on at the moment. Maybe down the road, 30, 20 years later or 100 years later, maybe you don't have to worry about that problem. But I think at least now you have to be very careful what you're doing. Don't rely on AI, especially for calculation. Many of the time they're wrong. Okay. But at least AI is good at doing software programming. So as long as you know what you're asking, they can tell you the right thing. So let's get started with Excel. So I hope you Excel in your hand, your iPad, or on your cell phone would work, or your Google Sheet also would work as well. So I start from scratch about Excel. So let's open Excel in your computer. Either you're the Mac or the Windows would work, but Windows won't work better a little bit because of the thing, but iPad I think also would work, except for the add-in function, but otherwise most of the function would work for your either computer. So you will see a spreadsheet, although now these days we have a lot of Python, R, or other high-tech software. Excel is still the software that's still widely used in business application in terms of number calculation. So it's still useful to learn. And I asked you several times during the class, and many of you told me that you haven't touched Excel at all. So I start from scratch. So you can see this is a spreadsheet, right? You can see spreadsheet, the white colors rectangle there are all this thing that contains cells, right? And these cells, you can put number there or formula there. So that is one of the main benefits of Excel is simultaneously display of data and calculation at the same time, which is not possible in Python or in other software because data and the code usually are segregated. So here is like you can see everything at once, so it's suitable for small set of data analysis. Okay, but although a good thing is the sheet there you can separate different thing in different spreadsheet. Okay, so that's a good thing. But now let's get started. Let's start with the simple thing. We use the spreadsheet as calculator. So how to do it is you can pick whatever cell you would like. In my case, it's A1. You double click it, and you have a blinking cursor there telling you that you're going to edit that one. And usually what you do is to do the calculator. So we do the standard thing is to add and subtract, do simple arithmetic. So what I do is because to do the calculation, all the calculation will start equal sign. Okay, we'll start with equal sign. Or maybe I make it bigger for people who see it clearly. Here is like this, and then you make it equal, and you try to put in the calculation you want, which we start with kindergarten 1 plus 1. Okay, and once you type it out, also appear in the top bar in the formula box here. Okay, and once you're done, you enter, then the answer is given to you. Okay, and you can do the same. For example, 3 minus 2, then it will give you answer, give you 1. Okay, and you can do all the calculation, addition, subtraction, right? And say multiplication, okay? And also say division. So you can try it out yourself, and you will see different types of thing. Okay, you can work it out again. And usually to demonstrate Excel, I use beside calculation, Excel is good, of course. Very famous, if you know, is for Excel function, which is a built-in operation that do the calculation automatically. That's the power of Excel because it do things quickly. So again, you start with equal sign, okay? And the one I illustrate is for illustration purpose. The most useful one is called the first formula I want to introduce is called the formula text. What they do is to show you formula text. What you're going to do is to show what is there, okay? And you have to tell the Excel which cell we want to look at. And in this case, you look and see all the cells are arranged by row and column, okay? And the first cell is called A1, okay? So if I put A1, okay, it will tell me this is the answer, okay? And by doing that, by pressing enter, they will tell me what the formula in this one. This is particularly useful when you try to show this formula to your boss or your client what you're actually doing, or you can check what's going on. Okay, so this let me save this file first because you don't know what happened when things happen because Excel often die. So the good thing about Excel is you don't have to type every time because the programming tells us what. If you type every time, it's not programming, right? If you learn any programming in your high school, you learn programming is to safe typing, right? Use the loop, using if statement, using a lot of stuff to make things easy. And actually, for Excel to do easy, then it's a for loop there, easily introduced. It's a shortcut here. This special shortcut here is you can see every cell, you can see the right bottom corner. There's a rectangle there. Okay, move your cursor to the bottom rectangle, it becomes a cross, black cross. Okay, and there's an interesting shortcut. If you try to double click it quickly 2 times, double click, then automatically you will propagate out according to what is in there in the left column. This is super useful. When you try to what it's doing is try to move down the formula, and together you move the formula as well. So that is the most convenient thing when you try to do Excel. Okay, and those of you who learn Python will notice that this operation is also used in all the data cleaning purpose. It's a row operation. You apply same thing for each row, and that is things that you often do in Python as well. But Excel make it so intuitive. Okay, is that clear for the operation of Excel? But in any case, I go around to see any problem because we start from the scratch. In case you haven't learned Excel, then I start from beginning to make sure that everyone on the same page. I'll be quicker in the subsequent function, but at the moment, I want to make sure that everyone able to open Excel and able to handle that, and then I will go on real quickly because I assume that many of you have touched Excel one way or the other, but surprisingly, in the first class, you replied that half of you haven't touched any Excel, so I just have to be a little bit cautious about that. But usually, I run very fast for this set of slides. But in any case, if any question, let me know. Oh, you can use Google Sheet or Office 360. Yeah, online version will work as well. If you Google Sheet or Microsoft Excel, you can do the Office Sheet. You don't have to install that. I think you're a CSK student, then you have access to the Office, the online version or the offline version, both. Okay. Or any other special package would work, right? So if you use the Chinese version, WPS also will work. So it doesn't have to be the one that we're using. But just illustrate that because in the industry, it's always use Microsoft Excel, at least in Hong Kong case. So you can also do the exponential, this raised to the power 2. So just let me do it quickly. Here, if I do the, I want to raise the power 2, square it, right? 5 raised to the power 2, that's 25. Okay, so this is the formula there. Okay, just do the calculation. I hope everything is okay at this point of time. If there's no other question, I jump ahead to the next set of thing. But if you have any question, you can just check it out. Okay, and there are some basic functions that has to help you to see what's going there. Okay, you can do a square and exponential. Both of these will be useful when you work on a topic 3. When we talk about normal distribution, the calculation involves square root and exponent. That would be something we needed. Okay, take a square root. But I just do it quickly on the square root case. Okay, I go down here. If I take square root of 25, okay, there I get 5. Right, and that's what's going on there. Okay, and if I do exponential, exponential means you use the base 2.718 and raise to power 1, right? If you 2 and same, and if you recall, and this would be the thing you would do a constant compounding when you learn investment class. I think 3050, something like that. 3080, I think 3080. That would be the class that you will learn this kind of function as well. So now here is more like statistics. So we have 2 functions called count and sum. Okay, count means count how many number of observation there, how many number of data there. Sum is some of them, and you can easily see that here I have put a curly bracket over the data. The main reason is this is how Excel takes into data. Okay, you should put it in the what we call data structure. It's called the array. You should put them into the curly bracket to tell them it is a cell data. Okay, of course, in this particular case, if you ignore the curly bracket, it still work, but it means actually different thing. You work, but so I recommend you to do formally. So you have to include bracket because later when we talk about correlation, you have to set 2 sets of data. You have to bracket 2 sets of the set of X and set of Y. Okay, you see later. So that's why bracket is the correct way to do the programming. But of course, Excel is not very strict. So if you do things loosely, they will still pass by. Okay, but let me write down here real quickly what we are doing. So I have a function. I just type them up. I use count. Okay, and I put a bracket there. right? And the data is 1. I separate each data by comma, okay, and close the curly bracket and end the parentheses. Okay, this is how we do it, right? Every function would be have to be enclosed by parentheses, right? In particular, for data, you have to enclose it by curly bracket. Okay, so that is something that you have to be careful. And then because when we talk about covariance, all the things that they'll be like this. Okay, and also this practice of knowing the data type, very careful about the argument, is good for your Python programming. Okay, because that is or other programming you are learning. So be careful the data structure. Although in Excel you can be very loose, but this is how I do it. And you can do the sum as well. Suppose I just being lazy, I just sum 3 numbers. Okay, and that's how you're going to work it out. Okay. So once we have that, then we're going straight ahead. Is that okay for the count and the sum? Is there any question? If any question, let me know. I try to be not too fast, but if it's too easy, I go faster. I can see, okay, this seems too easy, I can go very fast. Okay, because I don't want to miss whatever there. Okay, so for this one, I'm not going to do it one by one because it's very boring. Okay, so as I mentioned in the very first set of class, you have run down and run up function, right? Run down, run up will be telling that whether you go up one digit or go down, right? The closest one. Not going to do it further because illustrate here. Okay. So what I want is to direct attention to the mean, which is our first data, right? Our first sum of statistics is the mean, right? Remember, mean is add everything up divided by the total, right? So let me open the another sheet, so to make sure that we are not too congested. Some basics. Okay. And now we go to mean. Okay. And to calculate the mean, the simplest thing is to do the average. Right? Average, you put a set number there, right? Say 1, 2, 3, 4, 5. Okay. Without any calculation, you know it's 3, right? 3 is exactly middle and distance, right? So that is the answer. Okay, so that's the answer. Okay. And usually that's what you should do. If you know the formula, you should double check whether it's right or wrong, right? So usually what I would do is to apply the formula from scratch. So what the average is doing is sum of the observation over the number of them. So sum of a count. So that's what I will do. And actually you should do as well is 1, 2, 3, 4, 5. Okay. You have that. Okay. And then you have the count. 1, 2, 3. 1, 2, 3, 4, 5. And then you know 15 over 5 is 3, right? Yes. I think I don't need to write this, right? Okay. Then you know the two solutions are the same, which confirm that the formula there is the right formula. And although this is amazingly or embarrassingly simple, but that is what you should do, right? You check the formula given by the software actually fits what you expect, especially when you look at new unfamiliar formula there. Okay, so that is something that you should be doing. Okay, and one thing at the moment now you can see at the beginning I said you can have a simultaneously look at the data and the formula at the same time in Excel, right? I didn't show it because data have to type out directly. Okay? So I want to show you is you can have the data and the formula at the same time. Show it to you. Okay. So what you would do is you would have the data on one column or one row, and the thing on the other one. Okay, so usually you would maybe data is here. Okay, and then you would try to do the data. Let me do it vertically, or you can do horizontal, doesn't matter. So I do vertically. So that's why here is I have a bunch of cell here. Okay, let me put the yellow here. Okay, this is my data. Okay, and the data is not going to change. Okay, now I want to do the formula here. Okay, and here is I want the mean. Okay, for example, and by displaying the data here, you can actually use the function. Okay, but now I'm not typing the data directly because I want the data and the formula separate, right? So data is there. So what I'm going to do is to tell Excel where to get data, right? Where to get data is what we call cell referencing, right? You're pointing to where the data is, okay? And in this example, the data is between the cell C2, C3, C4, C5, okay? So just tell the Excel, I want to get the data from C2, C3, C4, C5, okay? And the easiest thing to do is to say C2, okay, which blue is there, because it's a continuous rectangle. You can put a colon there and put C5. Oh, sorry, C6. Okay. And you can see Excel very nicely highlight the data you got in the blue rectangle. And once you close the parentheses, then actually the Excel will give you the answer. Let me do the formula test here to illustrate the idea. So that's how you separate you have the data and you have the calculation. Okay. And one of the good thing about Excel is, or the bad thing is, if you change number, say suppose I change to 50, that's what, right? The answer would change immediately, right? So it's a good thing is because things can be seen very quickly, right, with your typo. But the bad thing is if you having a mistake, right, accidentally change the data, then have a problem. Okay, and that's why Excel sometimes you call the protected sheet. You will not allow things to change on that set of sheet, but it's beyond the scope of covering. You can easily check how to do that. So, but you shouldn't change data that much. Okay. Now mean. The next thing we want to do is median. All right. And the median, again, the formula, you can see the notes. I'm not going to go through the slide, but it will be just median. Very simply, either you can type out the cell range, or you can use the mouse, which is the most convenient one. You can just click and drag and release. Okay, and that's how it's done. Okay, okay, that is mean and median. Okay, I would expect you to know Excel because they will be asked in the assignment and also in the exam as well. Okay, I will not ask you to operate that, but I need you to know which formula would be using. If I ask you to calculate the formula, I expect you to write that for me, right? Either you write in the left-hand side way or the right-hand side way, right? Depends on what I'm giving you, right? If I tell you the data is from where to where, then you just write the right-hand side version. If I tell you what data is, then you put the left-hand side version. Okay, so that would be the median. And the central tendon is the last one with the mole. Okay, let me quickly finish this one and I go around to see if any problems. For the mole, for the Excel, there's some issue when you have more than one mole. The Excel function is only able to export one outcome. Okay, and if you want to export more than one outcome, you will use the array function. I think it is slightly beyond the thing we want to cover. So we focus on the case we only have one single mole there. But to illustrate, if you want more than one mole, you have to use another what we call array function, which you would have to press shift and control before you press enter. but I'm not going to go about that for our class. So the standard function will work for our class. We're not going to do that complicated. So we used to use the mode doc. There are two things, mode doc single and mode doc multiple. As I said, the multiple would give you an array which is beyond the scope of class. We just use the simple function. If you want, you can check out the internet. There are so many tutorials on that, because I don't want to confuse. If many of you haven't touched even Excel, so I'm not going to that approach. I will just use the mode single, okay, which is only give you the single mode, okay. And I just click and drag, okay, and you will see it's NA. You may ask why, because I told you, in many softwares, some of them would say that if everything appear once, there's no mode, okay. But we make our formula easier in the case that if everything there is everything, okay. But to demonstrate the result, okay, let me change a number in the data, so makes it 3, then this there, okay. So that ends the first part. We done the central tendency, okay. Let me spend 1 minute to walk around to see if you have any question with the mode, mean and median. Then immediately go to range, IQR, standard deviation, coefficient variation, so on and so forth. Let me know if you have any question, because this is more like tutorial rather than the lecture. So I want to make sure that every one of you is able to make sure that you are done, because you'll be doing this in your exam, in your assignment, and then you'll do it in your work, right? Working in Excel is something that is super important. Yeah, that's good. Okay. I know it's very trivial, but make sure that everyone knows it, because I don't want to leave you behind. Okay. Now, once you're done with this, okay. And let me go to create another spreadsheet that calculate the dispersion. Okay. I start data. Again, I have data 1, 2, 3, 4, 5, maybe 6 and more. Okay. And this is my data. Okay. Of course, you can have a row, but I just make things easier to see. Okay. Then start with the range. First, okay. If you recall, range is the maximum minus minimum. The largest number minus smallest number. And luckily, Excel has a function called max that gives the biggest number. Mean gives smallest number. Okay. So the range is simply max minus mean. So how to do that? Very simple. We just use max, okay, over the data, which is A2 to A7. Either you click, highlight, do the max. Okay, max minus mean. So immediately, to make our life easier, you just make it a single function. Okay, and once we've done that, that's the answer. So the formula is just simply max minus mean. Okay. So for IQR, okay, it requires you to do two things. First is to find the first quartile and the third quartile, right? If you remember, it's Q3 minus Q1. Okay, so that means that I need to know the quartile function. And I have told you there are many ways to calculate quartile. At least in Excel, we have two, okay, which is the quartile exclude and quartile include. Okay, the way we calculate that, why the difference? You look at the formula. Is whether you actually related to whether you include the median into the first or second half. That actually we do that. But the formula we talk about in the class is called the exclude, and also used in Python as well. Include is not, I think, do they implement in Python? They implement R. Python might be, maybe as well. But why I talk about exclude, because exclude one has a better property, much nicer. So that's why the one I use there. So how to calculate Q1 and Q2, right? And Q3. So maybe I talk about Q1, Q2, and Q3 first, right? How to calculate Q1, 3 first, and then I count IQR. Make our life easier. So there will be quartile exclude, as I said. Okay, you just quartile exclude, and then you put in the data you want, and then you tell them whether it's first quartile or third quartile. The median is there, but we got a median already, so we don't have to worry about that part. From Q1, you put 1 is Q1, so that is Q1 there, right? Of course, you want to check whether it's correct or not, right? You can actually using your what we said is n plus 1, which is 7, right? And 7 divided by 4 is what? 1.745, right? And then you pick the first one and 75% between 2 and 1, right? That's why 1.75. Okay, you can check whether you understand this one. Okay. And the second one, Q3 will be quartile exclude. Okay. Again, you have this data. Okay. And then you have quartile 3. Okay. And then that means that the IQR will be just you subtract these two numbers there, right? You can just take C3 minus C2. Okay. Of course, if you don't like this, you can do it once and for all, right? Because some of you would be very talented in software and really want to make it more complicated than you want. This is a good way. Okay. Want to call 3 quartile 1. Okay. So it's also IQR 19. Go. So either you have this row or this row the same, okay? But you would ask me if I like the 1-line formula or 2-line. I recommend you do several lines. It's more clear, right? Because you know what's going on rather than you put everything scramble into one formula. Because you scramble things in one formula, then it's able to check. Okay. And in old days, you have a restriction on number of rows you have, but now the computer software have so much memory. I mean, you never run out of the formula. You can go as long as you can. I don't think you have any problem. In old days, I think they fix it to 60,000 rows, but now I think you can go as long as you want. I mean, as your memory allow, so we don't have a problem. So it's quartile. Okay, is that okay? So remember our class, the formula used is exclude. Okay, and the next property is what is variance, right? And standard deviation. Okay, but variance, remember, we have two formulas. One is population variance, the other is sample, right? So in that case, we have population variance. And population variance is called var dot p, population. And you just highlight the data. Okay. There you get the var p. Okay. And similarly, you have the sample variance. Okay. As you expect, there will be var dot s. Highlight that out. Okay. This will be the formula. Okay. And the question, immediately you go to standard deviation. Okay. You may want to ask, okay, why with the standard deviation? Because I can take a square root of the variance, right? That's done, right? But I mean to be fast, so there's a formula directly. It's called STD EV. Okay. Again, there are two versions, right? It's the population SD and also the sample SD. Okay. So population SD will be STD EV dot P. Okay. A2 to A7. Okay, this is data, right? And then STDEV top S, A2 up to A7 will be the sample SD. Okay, so that will be done with your dispersion. Of course, we talk about coefficient variation, which is something very simple. But before we go there, I hope that's okay. This spreadsheet I'll upload to the Blackboard, okay? Unless the computer dies, I can upload, but I think it's very pretty clear. So I go around to see a new question, because these two calculations is mean and variance is you do all the time. Is that okay? Make sure you are fine, okay? Because we just do once, right? Well, we are not going to do every single class on Excel, right? I think this class is the most Excel incentive class, because after that, I'll just introduce the formula, this calculation, and then done, right? But now for this class, I will be more hand-holding on you, right, in the kindergarten style. But after that, I assume you become Excel expert, right? Then I will just talk the formula directly without holding your hand that much. Is that okay? Good. I'm very happy. So now the next is about the series, right? So you have two things. You have the population series and sample series. Okay. And remember, what is series? Series is the coefficient variation, which is the SD over the mean, right? If you remember. Okay. So that means that the formula we have is just very simple. STD EV dot P A2 up to A7 divided by average A2 up to A7. So that's the, right? Because we have the numerator and denominator are all there. The fraction, it's a ratio. Is that okay? Once I type it out, will be the formula there. That's right. And you can easily do it. Maybe I just wait 1 minute for you to do the sample series, right? Because otherwise, I do everything there, then you would be too simple for you guys, right? Just have some fun for you at least. You don't want to buy me copy what I'm doing. Hopefully that would help. The question, please ask me. Right? Give you some slight challenge on the population series, sample series. Okay? It's a much more challenge. Any question, concern, query? But just to remind you why we calculate CV during this time is when we compare different data set, right? You want to compare variance or dispersion, right? Compare, then this is how we do, right? Because I want to say compare dispersion between the marks in the midterm and final, that different range, right? Midterm may be maximum 60, but the final maximum 100. Then you want to compare the data set, how compare variation, right? Just to remind you that although I said midterm, I have no midterm in this class, okay? In case some people panic about the midterm, there's no midterm in this class. So don't ask me about midterm. Okay, so let me write down the sample CV there, and so that you know what's going on. Okay, the sample CV will be just standard deviation S, right? Because that is how you calculate the numerator, which is A2 up to A7. Of course, you can depend on the data you write and just average the same thing. Okay, so this gives us the sample CV. Okay? You can try to use this set of Excel tools to use to double check the example we have in our slides. Okay, you can check whether you get understanding. It's just this is how you do, right? So try to apply to the data you create or the thing you find there. Okay. So now, before we go to break, we want to talk about two more things. It's about shapes, right? It's about dispersion and kurtosis. It's about the kurtosis and skewness. Okay, this is about dispersion. Okay, and let me go to the one is called the shape. Okay, One thing about Excel is copy and paste, right? So it's Control C and Control V. That's how I'm doing. Okay, because Control C and Control V are in Excel, right? So I just copy that. Okay. The same thing, you can type it out. So what I do is I have the skewness. Okay, we will have the population skewness, and we also have the sample skew. Okay, two things. Okay, and the population skew will be the skew dot p. Okay, as I mentioned in the class, you very rarely use the skew dot population, so that's why Excel still keep it for you, but you will type dot p to signal that you want to calculate population one. But as I said, usually it's very rare that you do the population version, right? Unless that is the data that you want to study, right? But and then this case A2 up to A7, okay? And that's give you skew 0, which you expect to be true because this is 1, 2, 3, 4, 5, 6. Oh, but anyway, make it more fun. We make it 600, then it's a positive skew. Right? Maybe not so extreme, 60. Okay, so it's the skewness is like this. Okay, is that okay? And if you want the sample skew, which is more fun, I guess, be like this. Okay. Okay. So this is the answer. Okay, this positive skew as you expect because there's a very last number at the very end. Okay, is that okay? And before the break, I'll talk about kurtosis. But the kurtosis, as I say in the class, you don't use the nice formula for the population one. The one Excel gives you the only sample excess kurtosis. So it's called, I think, kurtosis. This is sample kurtosis. So remember, you care about excess kurtosis, so probably you have to give -3 in order to calculate that. Okay, I think that's pretty much for the first all the calculation that we want. Okay. I think this is the excess kurtosis already. Sorry, excess kurtosis, which -3 already. So this is the formula that it's like this one. This is the this guy. Okay. So this pretty much the first part with the break. After the break, we talk about correlation coefficient, covariance, and other Excel add-in things. But that would not spend us more than like 20 minutes. Then we'll go to probability. Okay. So let's have a break. Of course, because add drop period is still there, so I'm not going to take attendance, but I would do a new reply to ask you how well you're doing. And I will do that. Anonymous. So I want to again ask you how well you're doing, and feel free to leave a message if you have a comment or question. So let's break. Let's break up 15 minutes as usual. So we will resume at 11:35. Okay. Without a break, you have time, fill in the form, anonymous, and then I'll go around to see if you have any question.
你打3咧，佢可以聰明啲啦，都寫4。但係佢拉方面差唔多，我哋超閪，你個慢慢就話呢個好得拉嘅好出嚟嘅。即係呢啲你啱就講咗，高嘅數。即係如果 set up 呢個，我 set 曬。分組 rap 嘅，成個冇學過嗰啲，記得咗就呢個都困難。我真係唔知。有兩出嚟。哦，要撳遠一個都撳遠上去，但係其實考試就撳多個。哦，呢場哦，係啊，場案，有冇睇到？冇問題。你乜都有？你有冇做緊啲嘢對？The doses, skewness, sample skewness, Q skew. Skew 嘅你睇佢係如果正嘅話，譬如我有多嘢數，都是 skew。咁其實你唔加 P 咪就生，我唔加 P 啊，加咗 P 就係得你就係俾錢出嚟。咁我就學嘅都係其實上都幾強。係呢個 procedure 嘅，做緊呢個呢啲做嘅啲嘢。你放 break 我嚟做翻你上學，做我都估唔到，我又做事，做乜我都俾你唔好喺度睇咩反動啊，唔知不雅嘅，做乜都唔俾，冇辦法我俾我知我唔知嘅，我唔知啊。咁其實做都唔會冇理，佢擔心，我唔係好介意，有人喺度打麻雀嘅，佢網上打麻雀，唔係咁我咁樣擺咗帶埋個麻雀嚟打就睇，有啲好唔好睇，我都俾面佢，嗰邊係咯，You want to check out that part, I guess, not and then all the basic things, at least something all the time. It's just got some specific in English. Otherwise, please check out the recollection. What's happening? There was also caps, so you know,我係3年制嘅大學4年制咯，好玩。
Series of workshops.
都是 population 嘅，有冇人用？你嗰啲咁嘅，你可以自己整出嚟嘅，佢就冇咁樣。呢度點樣講？Math concepts being multiplication, division. That's the operator power and stuff. I like to meet those school math.
SEP.
Logic is like what happened air. The more name. 一鏡頭唔係佢整嗰度睇嘅，你唔得實係。大頭比較同，係冇咁正嘅。
I don't think this changing to people.
係用識 AI 做嘅。 裝對晒嘅。
我落咗。哦，對，那就一點。對啊。
你幫我播出嚟，做一次得㗎。可以落咗。我就而家做裝嘅，我遇到呢啲咯，跟前錯。係啊，好大，裝好大，認真。咁正嘅對然之後我做晒，然後吸咗佢，跟住你自己改。我從來有嚟講，一行你就播咗花咯，但係佢差到幾多點？差到。大充滿你每日，但係咁你大預防幫。好似係要實力先，點解你會做嘢好科技產？
冇錢啊！哦，誒，
Yes, we can slowly resume as we are looking at how you're replying. And I saw 25 people log in, but 11 fill in, but it's okay. Let's see what do we have. At least 11 is a valid point. Can I talk a little bit slower? Okay, I try. Is it that fast? But I try. Try hard to understand concept. Just make sure that we don't have new concept in this class. Right? If you recall, I just what I do is just tell you what the Excel formula is. There's no new thing, but in case you forget, then probably you can check back the slides and also the record lecture. Okay. The assessment scheme for this class will be, just to remind you, is 40% is exam, which we will try to schedule once the agile period is over. Likely the last class or the during the makeup period, because I want to have the parallel section for both. Okay. the terms are difficult. These are the terminology that we have to use. Unfortunately, I can't really skip that part. So they have to be there. What else? Okay. Yes, that's what I cover. So far in this lecture, we cover Excel. Okay. And the speed is okay, although one complaint is too fast, but I guess most of you are fine with that. And difficulties is also okay. I think I'm very happy about that part as well. I'm hungry. Sorry about that. Love my pants. My pants is like many years ago, so I've been there like more than 10 years. I want to have a new one, but just to save the earth these days, so probably you may see me a new one very soon, but not right now because I try to wait until the end of the day. But my wife joked about me. I mean, what are you doing? I mean, you dress so poorly, and then that reduce the incentive for students to study because you see the professors are so poor. But honestly speaking, like professors are poor, most of them. I mean, compared to many people say in the US, right? People go to school, the professor just drive a cheap car and the student drive expensive cars. That happens. I think same here. I mean, many students are super rich and professors are not very rich. I mean, especially B school. And B school students tend to, once they graduate, they work in a very good job, then they figure out that professors are very poor. But happen to be the case. But anyway, so let me continue our journey. I hope we are okay. So the two last thing is covariance and correlation, right? So let me have the data here, okay? So it's called relation. Okay. So now data I have X and Y. So just what I do is X and Y. Okay. My X is 1, 2, 3, 4, 5. My Y's are 9, 8, 5, 2, maybe 6, say. Okay. I don't know that would be fitting, but let's do this one. And by construction, you can see somewhat negative related X and Y. You can do whatever you like. Sorry. But this is the one I put in. So the first thing is you have covariance. So covariance, remember you have two versions, population covariance and sample covariance, right? And correlation coefficient have only one thing. So two things, I have population covariance, okay, and sample covariance. Okay. And the last one will be the correlation coefficient. Okay, there will be only three things we cover, right? Because this all the Excel will basically tell you what everything can be done quickly. Okay. Population covariance, simply just covariance dot P. Just covariance dot P. Okay. And do you know that you have to tell them two sets of data, right? X and Y, right? So if you input it, you have to do the bracket, right? But in this case, we just separate them by comma. So I have data 1, 2, 3, 4, 5, A to the A6, and a comma because another set of data. Okay. So this is how you would ask them. Okay. Let me do this. And this is how I do it. Is that okay? And I think you know how to do the sample version by analogy dot P become dot S. Covariance dot S, the same thing. Okay. You can do it by yourself, but let me illustrate as well. I think you should then be surprised by how to do it. Okay, and this how give you the larger number. As expected, the sample version is larger. Okay. Okay. And finally, this is the last thing we want to do. is about correlation coefficient, which is COREL, correlation. Okay. And do remind you that correlation coefficient has no population sample, only one version. Okay. So just the same procedure here. Okay. So that's pretty much done. Want to save with Excel for the basic functions. Of course, I'll talk about add-in as well, but at this moment, I think you are get all the calculation quickly, right? Because this is what we do. Okay. Is there a question? Just make sure that you understand how to operate them. Of course, in the slides, I tell you more. You may want to check them out. But here, I think I talked the main thing there. Okay. I'm not going to cover slide one by one, especially for Excel, because that would be too time consuming and not worth the class time. You're advised to read the slides carefully. Okay. But I think almost everything is there. Okay. Of course, as I said, I'm not going to ask you the thing that I didn't talk explicitly in class, but for your own benefit, please read it. You have to put a comma there. You have to put a comma between the two items. You get it? You see there? It's a comma there. Yes. Equal.
Or is he just going for an error?
No idea, but we can check it out. But maybe Google have a little bit slightly different formula. You can check it out. But this is the formula for Excel. So that's pretty much. But before we do that, I want to illustrate, probably you know already, quickly, how to draw graph quickly in Excel. I think you know already, but just in case you don't know, you go to Insert, okay, and here a bunch of data. Okay, I think you learned it in the high school already, but I just illustrate the scatter plot. So what you're going to do is to highlight the data, and then you can go to scatter plot, which is here. Okay, and then tell them I want this guy. Then this will give you the answer. Okay. So this will be the thing that you should showing your boss or your customer, your client as well, right? The visual representation. As I said, I don't want to cover this because you should have learned it in your high school, or if you question, there are many tutorials you can look at, right? Because I think our class is supported by data camp, so everyone will have access for 6 months, 3 months beyond this class. For the premium subscription, you can see whatever thing there. Okay. So then that in that website will tell you many of the software skills. Beyond Excel, you have Python, R, a lot of stuff there. But okay. So after that, I want to talk about something. It's very important for our class. It's called Excel add-in. Okay, this is the package. So add-in is maybe difficult to do it in. Maybe also do it for the Mac, but mainly for Windows. But Mac, I think, is still workable. Is to make our calculation even faster. Okay. If you want to do something quick, this Excel add-in will be very helpful. For example, we spend a lot of time to calculate all this, but Excel add-in can do it right away. Okay. So let me do the add-in, and this is basic. Maybe I just NS2 pen. Okay. So what I'm going to do is to do an Excel add-in, a little bit elaborate things to do before you can work on now. Okay. But first, you have to be careful, listen. File. Okay, let me repeat the same. File. Macintosh can also do it, but you go to more, where the option. Okay, file, option. Okay, file, option, and then add in. Okay, file, option, add in. Yes. Let me redo here. I think it should be fine for your Mac to still be there. If you use Windows, it will be file, options, and add in. Okay, and then you go to go. Okay, and here you're the first one is not tick. Make sure the NS2 pad is click. Okay, I think you can also do that in the Mac, but some other way wrong. But in the past, people can do it in Mac, but I don't have Mac, so I don't really know too much about Mac. So once you're there, you should be able to see in the data here a new thing called data analysis. Okay, so make sure that you know you are okay with that. I'm sorry if you use iPad, you can't have that, but only exists in the computer version. I think Mac also can have that as well. If you don't know, you can ask your AI to help you to figure that out, because I don't have the Mac in my hand and also don't hold any Mac. But it should be there, it should be okay, because in the history, people can do in the Mac class. Okay. Now, what you do is once you click on it, you will notice that there's so many stuff. And actually, we will learn majority of them. Or if you don't, even not all of them, but you will know how to use the rest of them pretty easily, but very similar. Okay. And the thing I want to talk about today will be three of them. It's actually these correlation, covariance, and descriptive statistics. In particular, this one. And you will learn the rest in the other class, okay? Later in this course. Okay? But this descriptive statistic is the most important. Okay. But let me show my data first. Okay. My data is 1, 2, 3, 4, 5, 6, 7, 10, say. Okay. My data. You can do whatever you like, but this is my data. Okay. Now go back to the data and data analysis. And then you go to descriptive statistics. Okay. Is that okay? I mean, those who use Mac may be a little bit tricky, but you should see this guy. Okay. Somehow by some method. Okay. Because in the past, we were able to do it. Now, once you kick in, you have seen this dialog box will tell you what you should do. Okay. And that's not very complicated. You just tell them where your data is and where you want to put your output. Okay. First one, input. Just tell them what your data is, say suppose here. Okay. And once you're done, because the data have label, I put label in the first row. The next is, once you do that, you would tell them where you want to output the data, which is output range. Okay. And then you tell them where you want to put it. Well, sorry, this one screen is gone. In this particular case, what is that? Back again. So I put it C1 or whatever you want to start, maybe C1. Okay. Once you do that, okay, maybe I want some statistics. That's what I want, right? That's what I want to have. Once you're done, I click OK. Then everything is brushed out in 1 second. Okay. So let me do it. Is that okay for this one? Because already there, I think it's not too fast. Okay. Now you crunch out the whole thing. Okay. So you have the mean. Certain error is not covered right now. You learn that in later chapters. And we have mode. We have SD, sample, variance, kurtosis, skewness, range, mean, max, sum, count. Basically, you splash out quickly. Okay. So maybe I do it again using a different data set, right? X and Y. Okay. Maybe I use another color. Green, maybe a little bit green, right? Maybe I do another set of data, right? Maybe 2, 5, 5, 4, 5, 6. Okay. Maybe this is my data. Okay. Let me do it again in case you haven't seen the first time. Okay. Now the good thing is the some discrete statistics can go for 2 columns, just one. Okay. That's why it's so convenient. So I just input, I change it to 2 columns. Okay. And my data is grouped by columns, right? Because each column means one variable. Okay. Same thing here, the same thing there. I click OK. And then once I click on it, you will see very conveniently, you give me 2 variables, what the mean, median, mode, FC, total skewness range. Okay? So that's why I talked about all this in my class, because Excel output give you all this. So by now, you understand every single there, right? So everything you can know, because we know how to tell you which formula gives you this formula, right? Of course, the bad thing about this quick analysis is don't have formula, right? So just number there. So you can't check where it comes from, but already you know where they come from. Is that okay? There any questions? In the question. So as a final illustration, this one can also generate the covariance and correlation as well. As expect, I do data analysis, and I have the covariance. Okay. And similarly, I want to tell them where my data is. Okay. The data is just A1 up to B9. Okay. And I've labeled in the first row. And I tell them where my output is, which is here. The output will be just here. And once I click, they will give you the covariance. Okay. And I do the same for the correlation. Data analysis, correlation. Click OK. And tell them what the input. My input is A1 up to B9. First row is there. Output is here. So don't worry if you don't fully follow the add-in. It's not compulsory in our class. It's just optional that you know what's going on there. But you will learn doing the rest for the rest of the course, how to handle add-in. But otherwise, I'm not interested in asking you how to operate add-in in your assignment or in the exam. I want you to know is the thing before the break. Okay. This thing is just to tell you that there's some way you can do it quickly. And also there's some way to do things much faster. But this is how Excel will be done. Okay. I think this is pretty much about Excel for today. Any question before we start our new chapter? But this is add-in. Okay. I now upload this file to the Blackboard. So in case you are you want to see what's going on there, you can check it out by yourself. Okay, my file and also the classes record. Luckily, if everything goes smooth, then the video has sound, so you will be able to see it. But if not, then you will see the record from the other class will show everything very nicely. So I hope it's okay. Any question before we go to the chapter 2? So we're done chapter 1. So some calculation, how to tell the number from the data, and how to draw a graph. We know so how to do scatter plot. You should know how to do different type of plot, bar chart, pie chart, right? And also now we have all these things. Now you understand what the kurtosis are, what the skewness are, all the numbers you're able to see. Okay? Any further question? No? No, then we are going to work on probability. Any question? Something to ask? No? Okay. Now we have fun. More fun. Okay. Any question? So probability is something that you already learned. Forget, but anyway, you learned something in your high school. Okay. So of course, that's why we need to be a little bit higher to tell you a little bit more complicated thing. Okay, because this will prepare you for more for other classes. Okay, and you use it in your investment class, and also use it in many other operation management or those kind of things. We require probability. So that's why we need to cover this right now. Okay. So what happened? Okay. So probably the question, the first is, what is probability, right? I mean, what is probability about? Okay. And before we're going to slide, so let's see what probability. Probability simply means there are many definitions if you look at philosophy. I'm not going to get into philosophical discussion, but what are we doing in probability is like the way to quantify uncertain future. That's what I define. The quantitative way. And the probability is a measure between 0 to 1. And 0 means never happen, and 1 is most likely. Okay, it's the way to measure. Okay, that is exactly what's going on. And in advanced mathematics, they will tell you this is how you try to measure different kind of sets. It's a little bit more complicated, but the way that we put it is in business decision, right? Or finance, investment, or insurance. There are a lot of things will be happening in future, right? So things didn't happen, and then we want to quantify something that is more likely to happen than not. That's probability, right? And we often know because of typhoon in Monday, we all know that what is more likely, what's less likely, right? They will tell you let's go back to that one, right? We often see that in the observatory, right? We actually give you the probability of typhoon graph, right? Usually you will see this type of graph. Right? You will tell you the color tell you the probability, right? Blue is very low and red is very high. So the like this. It's not there, but somewhere like this style, right? And right, the red one very most likely, and this is the blue one. Okay. Of course, how to do calculation is the job of engineer. I think none of you are engineers, so that's okay. Someone give us this graph, right? And then we know that if you are the guy, the red guy, right, near this one area, right? If you are blue, be pretty safe. In the white area, we don't have to worry about things, right? So this is probability, right? Because this quantify how things are going to happen. Okay. So now we know what rough sense what probability is. So let's define probability in a classical way, and we'll tell you that the classical way is not sufficient. And classical way, if you learn in the high school, is called long-run frequency, a ratio. If you do some experiment, okay, you repeat something, right? You toss a coin, roll a die, and you record how many of them. It's a fraction, right? That's why between 0 to 1. Okay, let me start. Okay. So let me start with random experiment. That's how classical probability start in the 1700 when they talk about gambling. Okay? And that time people doing this are mathematicians and they're very rich, nothing to do. Gamble is something they like to do. Of course, they're not gamble in the Macau, like gamble $1,000 billion, $1 million. They like to gamble $1, $2, $3 just for fun. Okay. And at that time, people want to think about different type of gamble and what is a fair way to gamble. What is the odd ratio? Should be there, right? But that is really the probability. But let me start with random experiment, right? And what we learn is someone's going to do, it's going to happen, but we don't know which outcome will happen, what may happen, but we know what are all possible things can happen. Okay, very important statement. Let me repeat. So we assume that we know what might happen. Okay, but we just don't know which one may happen. Okay, so that is a very strong assumption there because it never surprises in some outcome. It only surprises this outcome actually occur. Okay, what does that mean? It means that I toss a coin, it is either head or tail, right? If I put my hand into my head, okay, either some hair comes out or no hair comes out, right? It's not like I put my hand in my head, a rabbit comes out. A rabbit comes out, surprise me, right? Unless I'm a magician, right? Otherwise, I don't expect something comes out, right? So there shouldn't be something happen that is not in our consideration, okay? And the classical thing also impose a constraint is it has to repeat itself many times. Potentially have been repeated and potentially can be repeated many times. Like toss a coin, roll a die, you can repeat, right? And why? Because that's the way you quantify, right? You can do experiment enough in history to quantify, right? It means that for things happen in the past, we can't do it, right? For example, how likely that a UFO will come? I don't know. That's no one knows, right? Or how likely a dinosaur will come out again? I have no idea. There's no probability can assign, right? Things happen once in a lifetime. You can't really assign probability, right? For things happen again and again, you can assign probability, right? So that is a very important restriction in the classical way, right? So the first is random experiment. Let me repeat: is something will happen. We know what might happen, but we don't know which one will comes out. And this kind of experiment potentially repeat because it's like gambling, right? You can repeat things. Okay. It works for science, engineering, but doesn't work very well for business, right? For example, you want to ask how many customers are going to come. Okay, this is okay if the business have been there for many years. You have data to guess what the probability is. But your business is just a new business. You're selling a new product. The probability cannot be done in this classical framework because it has been done in the past that give you some idea how to get the number. If something's new, I don't know. No idea. I have no basis to judge. Of course, you can use some other information, but that is difficult to say, right? Suppose, just for the sake of illustration, suppose there's a beautiful woman here, okay? A stranger, I don't know her. I want to get her telephone number, maybe get her IG or WeChat or whatever, right? So what's the probability of successful? There's no way to guess because unless the parallel universe, okay, you see me doing this in 1,000 parallel universe, out of 5 of them successful, maybe I do 1,000 universe, I can say the probability, okay? But there's no multiple universe, I can see it, okay? And what do you mean by probability in that sense is what we call in philosophy called Bayesian. That only represent how likely thing in my view, my belief. It's not about, it's just you think what happened. Okay, that is different from the classical point of view. It have to be repeat. Okay? And outcome is the outcome of is the thing that come out from the experiment, right? You toss a coin, head is an outcome, tail is also an outcome. Okay. Now we come a little bit technical. Okay. We have to define what's called event. Event is a group of outcomes. Okay. Any group. Suppose you roll a die, even number is an outcome. Sorry, it's an event because even numbers involve one. Even number is 2, 4, and 6. 6 face dice. If odd number will be 1, 3, 5. If you like, can be prime number 2, 5, 3, right? Or the prime number event, right? The group of them. And the last one is called sample space. Sample space means that it's an event that contains all possible outcome. Okay, that means the sample space is the outcome that it can happen. Okay, and in the classical probability, we know exactly what is the sample space. Okay? And if you don't know, that is a problem. But we have to know it. Okay, as I said again, the outcome is not surprising us. Is this particular outcome arises, surprise us. Okay, so that have to be very careful about this part. We have to, in order to model probability, you have to know what are possible outcomes. If you don't know, you do not know probability. So in this case, total a coin, the sample space is head and tail, and roll a die will be 1, 2, 3, 4, 5, 6. Okay. Now, this is the definition you learn in the high school. What's probability? Probability is nothing but just a fraction of what? A numerator is if you repeat the experiment many, many times, just like roll a die, roll many dice. Okay. What's probability getting a number 1, say, for example? You roll many times, you record how many times you get the 1. And that is the numerator. And how many times you roll is denominator. Let me repeat again, is potentially to calculate probability, you have an experiment, you can repeat many times. Okay. And how many times you repeat is the denominator. Okay. And the numerator is you count the outcome that's favorable to event. Okay. In this case, it's 1, we just count number 1. If you want the probability of even number, we'll be just looking at the number of rows that you have 2, 4, and 6. Okay, just this is nothing, just a ratio you learn in high school. There's nothing new there, right? So the example you even often ask when you do in high school is to go home, take a coin, roll 1 million times, right? Of course, probably in high school you only do 100 times, right? 1 million would be too crazy, but 100 times, and you record how many times you get a head, how many times a tail, and if you toss in a honest way, you should get half of head and half of tail, right? Unless you got a bias coin, right? Both side head, both side tail, right? Only happen in the TV, but not happen in the world. But half of them are head, half of them are tail. That means that the probability of having head is half, tail is half, right? And by the construction, the fraction is always between 0 to 1, right? There's nothing to say the probability is 200 or probability is negative, right? At least in this definition, right? Of course, some people will say the probability is 200, basically is nonsense, right? And probability is negative is also nonsense, at least that's this definition. Okay? To make you fun, I mean, if you learn quantum mechanics, actually they would allow negative probability. But anyway, it's beyond the scope of a plot. Right? It's always from 0 to 1. Now, next example, just to remind you that the green thing is I expect you to know very well. Okay, The purple thing is the thing that you should understand what's going on, but the green thing is the thing that's the key. So here, an example of a rolled die, a fair die of 6 faces. 1 is outcome, 2, 3, 4, 5, 6 also outcomes, right? And the sample size is all together. And in mathematics, we use a curly bracket to represent things together. It's called a set notation. I'm not going to go to set notation because this will involve, if you learn M2 math in Hong Kong, you know that. But for our purpose, we could put a curly bracket as we do in Excel, just to signal that this is the thing that is there. Okay? A collection of stuff. Okay, an even number is a collection, is a group of number is called 2, 4, and 6. Odd is 1, 3, 5, and large is 4, 5, 6. Okay, and the probability of even, odd, and large, if the die is fair, right? If you roll 6 million times, right? That means that each number should appear roughly 1 million times, right? So that means that the probability even will be a 3 million numbers, right? Because 1,000,002, 1,000,004, and 1,000,006. So that's why it's 3 million over 6 million over 6, right? The same for the odd and large. I think that's pretty trivial. Let me quickly go to the next one. Okay. And here is a very useful graph, what we call the Venn diagram. If you learn M2, you learn that as well. But that's the way to illustrate the event sample space. Okay. And you see the O is the odd, the 1, 3, 5, the green one. And the even, the red one, is 2, 4, 6. And last one will be 5, 4, 5, 6. Like this, with circle and the rectangle. And the sample space is the whole thing outside. So don't worry, we've seen this very often. This is called the Venn diagram. VENN is the graphical illustration of how things are related. And you often use this in business as well, right? To show how things are related. Okay, not just probability, but this is just how things are related. But there's no probability at all. Okay? Now, here, let's go to more fun, because this is how also you learn in the high school, right? Suppose let's not roll the die once, we roll the die twice. Okay? And we add up the numbers, the face up. Okay. Okay. So what are possible scenario, right? If 1 and 1 give you 2, right? 6 and 6 give you 12, right? So the possible outcomes are 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Do you note that although we list them out, right? But there are a lot of them, right? If you, in general, if you don't, you care about the order, right? 1 and 2, and 2 and 1 will be different. If you care about the sum, that is, they don't care about the difference. But if you care about the order, the 1 and 2 and 2 and 1 are different. Okay, so it depends on how you record. If you record the sum, you only have 2 up to 12. If you care about what the number they are, the outcomes are a lot, right? Actually, there will be 36 of outcome. Okay? We tell how to count it, but that is the outcome. So here you can see how what you consider outcome matters, right? And you have to decide for your own purpose what's outcome. Okay, that's so no universal set of outcome, right? It depends on how you simplify the thing, right? Or how you think what is matter, what doesn't matter. It's more like a depend application, right? Suppose the example continue, right? I asked a beautiful lady what is her IG, right? Quite directly, right? Maybe he just say no, one outcome. Maybe he slapped my face, another outcome. Maybe he just go away, an outcome. Maybe he just throw the water to my face, a third outcome. Maybe he say yes, give me her IG, is an outcome, right? But there are many possible outcomes. But you can just maybe simplify by yes or no. Also fine, right? The outcome can be just yes. She gave me the IG. The other no, she didn't. Right? So it depends on the purpose, and how complicated the outcome depends on the application. Okay? But in this example, if I just have to be careful Then I have to record everything. Then I have 36 outcomes. And you calculate probability. The sum of die less than 4. You can figure out that only 3 possible cases because 1 and 2, 2 and 1, and 1 and 1 is less than 4, right? Because 2 and 2 is exactly 4. So that means that 3 over 36 is the probability. Okay. So I will see you on Friday to continue a probability journey. Okay. Now, is there one other question? Very nice.